Hello student. Now in this video we will learn the square root of a complex number and solution of a quadratic equation in complex number system. First, square root of a complex number. Now consider here we denote the complex number, that is a z is equals to x plus iy. This is the complex number and we want to find out the square root of this complex number. Now here we will write the square root of this complex number, that is the a plus ib. This is the square root of this complex number. Therefore I will write here x plus iy in root of x plus iy, where a comma b, a and b belongs to set of real number. Here is also x and y belongs to set of the real number. We want to find out the square root of this complex number x plus iy, and we are considering this complex number, that is the square root of this complex number x plus iy is a plus ib. Now we will evaluate this. Squaring on both sides here, squaring on both sides, then what you will get, a plus ib bracket square is equals to x plus iy. Now a plus ib bracket square is equals to x plus iy. We'll expand this, that is first is a square plus 2ab plus I square and b square, and that is equals to x plus iy. Okay, now here a square plus 2abi plus the value of I square is minus 1, and that's why I will write here minus 1 b square is equals to x plus iy. Now minus 1 into b square, that is a minus b square. Therefore I will write here a square minus b square, simultaneously collecting the real part of this, plus 2abi plus 2abi, and that's equals to x plus iy. Now equating the real and the imaginary part, equating real and imaginary part, parts, then you will get, that is a square minus b square. This is the real part from the left hand side. Here is a x is real part on the right hand side. Therefore I will write here a square minus b square is equals to x, and the another part, that is a 2ab is equals to y. This is the imaginary part, this is the imaginary part. 2abi is equals to iy get cancelled on both sides, and that's why here you will get, that is a 2ab that is equals to y. After solving these two equations simultaneously, you will get the value of a and b, and that will be the square root of the complex number z is equals to x plus iy. Now we'll take the next part. The square root of the following complex number. The first complex number is minus 8 minus 6i. Let x plus iy is equals to a root of minus 8 minus 6i. Now squaring on both sides. Yeah, squaring on both sides. And what you will get, that is a x plus iy bracket square is equals to minus 8 minus 6i. Expand this, then you will get x square plus 2xyi plus I square and the y square, and that is equals to minus 8 minus 6i. The value of I square is minus 1, and therefore we can write here x square minus y square plus 2xyi, and that is equals to minus 8 minus 6i. Now here we will equate the real and imaginary part. The real part is here, that is a x square minus y square. This is the real part, and to the right hand side it is a minus 8, and the imaginary part is 2xyi. This is the imaginary part, and here is a minus 6i. We will equate here real and the imaginary part. It is here. Therefore you will get the expression x square minus y square, that is equals to minus 8. This is the first one. 2xyi is equals to minus 6i. That is I get cancelled on both sides. If we equate this, then I get cancelled on both sides, and then you will get 2xy, that is equals to minus 6. Divide on both sides by 2, then you will get xy is equals to minus 3. Now what is the value of y here? That is a xy. Here xy is equals to minus 3, and therefore y is equals to minus 3 upon x. This is the value of the y. We want to solve these two equations. Now we will substitute the value of y in this equation, that is the x square minus y square is x square minus y square is equals to minus 8, and here x square minus y square is equals to minus 8. Substitute the value of y, therefore you will get x square minus 3 upon x, it's a bracket square, and that is equals to minus 8. And we'll solve this. X square minus the square of this minus 3 upon x is 9 upon x square, and that is equals to minus 8. Now multiply on both sides by x square. If you multiply here x square into x square, then you will get x raised to 4. Minus 9 upon x square into x square, then you will get x square get cancelled. You will get here minus 9, and that is equals to minus 8 into, here is also multiplied here x square, then you will get minus 8x square. And therefore this quadratic equation, that is x raised to 4 plus 8 x square minus 9, that is equals to 0. This is the quadratic equation in x square. Now we'll solve this quadratic equation. The product of first and last term is a minus 9x raised to 4. Then what are the two factors? Plus 9 minus 1. Therefore the factors are x square plus 9 in first bracket, and in second bracket x square minus 1, and that's equals to 0. Therefore x square plus 9 here, x square plus 9 is equals to 0, or x square minus 1, x square minus 1, and that's equals to 0. These are the two equations. Now we'll solve this. That is, therefore x square is equals to minus 9 or x square is equals to 1. But x is a real number. What is it here? But x is a real number. X is a real number. Therefore, the square of real number is not negative. Square of real number is not negative. Therefore, x square is not equals to minus 9. This is not possible. Therefore, we take x square is equals to 1. Therefore, we take this is possible. X square is equals to 1 and solve this. Taking the square root on both sides, then here you will get x is equals to plus or minus 1. Now, when x is equals to 1, then what about the y? We have, that is, the y is equals to minus 3 upon x. Therefore, we substitute the value. That is, y is equals to minus 3 upon x. Substitute the value of x, which is 1. 3 upon 1, and that is equals to minus 3. The value of y is minus 3. Again, when x is equals to minus 1, then what about the y? Y is equals to minus 3 upon minus 1, and that is equals to this minus and minus, that will become plus. Therefore, the required roots are, the first is 1 minus 3i. Therefore, the required roots are 1 minus 3i and another is minus 1 plus 3i. Again, this we can write in this manner, that is in compact form, plus or minus 1 minus 3i. We have taken plus or minus. If we take plus, then this is as it is, and if we take the minus sign, then you will get minus 1 plus 3i. Therefore, this is the square root of the complex number minus 8 minus 6i. In this way, we can find out the square root of the given complex number. Now, we'll take the next example. Now, next example is 1 plus 4 root 3i. We want to find out the square root of this complex number. This is the third one. Is equals to square root of 1 plus 4 root 3i, where x and y belongs to set of real number. On squaring both sides, we get x plus iy bracket square is equals to 1 plus 4 root 3i. Now we will expand here, x square plus 2xyi plus I square y square, and that is equals to 1 plus 4 root 3i. Now again, we'll substitute the value of I square. I square is minus 1, and therefore here I will write here minus y square, minus 1 into y square, that is a minus y square, and also similarly add collected this real part, plus 2xyi, and that is equals to 1 plus 4 root 3i. Okay. Now equating the real and the imaginary part. Equating equating real and imaginary part we get equating the real and imaginary part, we get x square minus y square, x square minus y square, and that's equals to 1. Here we will equate it, real and the imaginary part. This x square minus y square, this is the real part on the left hand side, and 1 is real part on the right hand side. And next is a 2xyi, and here is a 4 root 3i. This is the imaginary part. We'll equate it. Okay, here the same sign. X square minus y square, that is equals to 1, and the another is a 2xy is equals to 4 root 3. If we equate it, that is a 2xyi is equals to 4 root 3, I get cancelled, and again simplifying, you will get divided by 2 on both sides, then you will get xy is equals to 2 root 3. Xy is equals to 2 root 3. Again we'll find out the value of the y there. What about y? Y is equals to 2 root 3 upon x. Y is equals to 2 root 3 upon x. We'll substitute the value of this y in this equation. X square minus y square is equals to 1. Therefore, put y is equals to 2 root 3 upon x in this equation. X square minus y square is equals to 1. X square minus y square, and that's equals to 1. We'll substitute the value. Therefore, we'll get x square minus, what about the value of y? That is a 2 root 3 upon x. It's a square, and that's equals to 1. After squaring, you will get x square minus, the square of 2 is 4, 4 into 3, then you will get, that is a 12, that's equals to 1. The square of 2 root 3 upon x is a 12 upon x square. Now again simplify here, multiply on both sides by x square into x square, you will get x raised to 4 minus 12, and here 1 into x square, that is a x square. Again simplification, x raised to 4 minus x square minus 12, and that's equals to 0. Now we'll factorize this. Okay, therefore the factors are, the product of first and last term is a minus 12, x raised to 4. Therefore, what are the two terms whose sum is minus 1 and the product is minus 12? Therefore, minus 4 and plus 3. The factors are x square minus 4 in first bracket, and in second bracket x square plus 3, that's equals to 0, and therefore x raised to 2 minus 4 is equals to 0, or x square plus 3 is equals to 0. Can we solve this? Therefore, x square is equals to 4, or x square is equals to minus 3. But we know that the x is a real number, but x is a real number. A real number, x is real number, and the square of real number is not negative. Therefore, x square is equals to minus 3 is not possible. X square is equals to minus 3 is not possible. Therefore, we take here, therefore, we get the second quadratic equation, x square is equals to 4. Now taking the square root on both sides, therefore, here you will get x is equals to plus or minus 2. And here we take, once we take the x is equals to plus 2. When x is equals to 2, then what about the y? We know that is the value of the y is a 2 root 3 upon x. Then y is equals to 2 root 3 upon 2, that is equals to, these two get cancelled, you will get root 3. And again when x is equals to minus 2, when x is equals to minus 2, then what about the y? That is the y is equals to 2 root 3 upon minus 2. Again these two get cancelled, you will get minus root 3. Therefore the root of the complex number 1 plus 4 root 3i is, what is the first? X plus iy. X is 2, y is root 3. Therefore the roots of complex number number 1 plus 4 root 3 are 1 plus 4 root 3 are, what is the first? X is 2, y is root 3, that is a 2 plus root 3i, and another is a minus 2 minus root 3i. Again we can compact this, or plus or minus in bracket 2 plus root 3i. Okay, and in this way we have completed the third example. Now we'll take the next example, that is example number 5. Now the next example is 2 in bracket 1 minus root 3i. We'll find out the root of these complex number. Now first is let x plus iy is equals to root of 2 in bracket 1 minus root 3i, where x and y belongs to set of real number. Again squaring on both sides, then you will get here x plus iy bracket square is equals to 2 1 minus root 3i. Next we will expand this, therefore you will get x square plus 2xyi plus I square y square, and that is equals to, now multiply this 2 with the 2 1 and root 3, therefore you will get minus again here 2 root 3i. Substitute the value of I square, minus 1, therefore here x square minus y square, I square is minus 1, minus 1 into I square is a minus y square, plus 2xyi is equals to 2 minus 2 root 3i. Okay, now here we equate the real and the imaginary part. What is here? X square minus y square is equals to 2, and what about that? 2xyi is equals to minus 2 root 3i, and therefore here you will get, that is the x square minus y square, that is equals to 2, and in second case 2xy is equals to minus 2 root 3. Okay, 2xy is equals to minus 2 root 3. And again, towards simplifying this, divide by 2 on both sides. Therefore, you will get xy is equals to minus root 3 and y is equals to minus root 3 upon x. Y is equals to, the value of y is minus root 3 upon x. Now we'll substitute the value of this y in this equation. We'll solve these two equations simultaneously. X square minus y square, and that is equals to 2. X square minus y square is equals to 2. Substitute the value of this y. Therefore here you will get x square minus, in bracket, minus root 3 upon x bracket square, and that's equals to 2. Now simplify this. Therefore here you will get x square minus, the square of minus root 3 upon x is 3 upon x square. Therefore I will write here 3 upon x square, and that is equals to 2. Now multiplied on both sides by x square, x into x, x square into x square, then you will get x raised to 4. Here minus 3 upon x square into x square, you will get here 3. 2 into x square. Now we can rearrange these terms. X raised to 4 minus 2x square minus 3 is equals to 0. This is the quadratic equation in x square. The factors are 1 into minus 3 minus 3. What is the two terms whose product is minus 3 and the sum is minus 2. Therefore the factors are x square minus 3 and x square plus 1, and that's equals to 0. Therefore here you will get x square minus 3 is equals to 0, or x square plus 1 is equals to 0, and therefore x square is equals to 3, or x square is equals to minus 1. But x is real. Again, x is a real number, but x belongs to set of real number. Therefore square of real number is not negative. Therefore x square is not equals to minus 1. This is not possible, and hence we take x square is equals to 3 is possible. Therefore x square is equals to 3. Now we'll solve this quadratic equation. Taking the square root on both sides, then you will get x is equals to plus or minus root 3. These are the values of x. X is equals to root 3, and x is equals to minus root 3. Now we'll find out the value of the y. Therefore I will write here, when x is equals to root 3, what about the y? That y is equals to minus root 3 upon x. That is, y is equals to minus root 3 upon x, and that is equals to minus root 3 upon root 3, and that is equals to minus 1. Next is when x is equals to minus root 3, x is equals to minus root 3, then y is equals to minus root 3 upon x. Okay, y is equals to minus root 3 upon x. Substitute the value of x, that is minus root 3 upon minus root 3, and that is equals to 1. Therefore the square root of the complex number, the required roots are what are the required roots? That is the root 3 minus 1 into I. Therefore, I will write here root 3 minus I. Minus 1 into I is minus I. And minus root 3 plus I. Or we can compact this, or plus or minus root 3 minus I. These are the roots of the complex number 2 in bracket 1 minus root 3I. And in this way we have completed the 3 examples how to find the square root of the given complex number. Hello student, now this is the second question. Solve the following quadratic equation. The first equation is 8x square plus 2x plus 1 is equals to 0. Now this type of equation we have solved in 10th standard, but these equations are different because the discriminant, that is a delta, is negative here. Now here comparing this equation with ax square plus bx plus c is equals to 0. We'll compare this equation with this. Now what is the value of a? A is equals to 8, b is equals to 2, c is equals to 1. The value of a, b, c. A is 8, b is 2 and c is equals to 1. Now we'll find out the discriminant, that is a delta. Delta is equals to, this is the delta. Delta is equals to b square minus 4ac. Okay, the value of b is 2. Here is a 2 square minus 4a. A is 8 and c is 1, and therefore here you will get 2 square means what? 4. 4 into 8, that is a 32, and their subtraction, that is equals to minus 28. Therefore the discriminant delta is a negative, and therefore as it is a negative in 10th standard, roots are not possible, but here we can find out the roots of this quadratic equation which are in the complex in nature. Okay, now we substitute the value, that is when ax square plus bx plus c is equals to 0. This is the quadratic equation. Therefore by using the formula, what is that formula? X is equals to minus b plus or minus in root of b square minus 4ac upon 2a. Okay, now here we will substitute the value. What is the value of b? B is 2 here. I will write here. This is minus sign, plus or minus in root of b square. B is again 2. That is, we have already calculated this value, b square minus 4ac, which is the minus 28. I will write here root of 28. Okay, this divided by 2a, that is the 2 into a. What is the value of a? A is 8. Okay, and therefore here is a minus 2 plus or minus in root of, now this is the 28 and 28 can be written as in this manner, that is a 28 means what? I will write here first 4 into 7 into minus 1, and this divided by 2 into 8, that is 16. Okay, now next is here minus 2 plus or minus. The square root of 4 is 2. I will write here 2. Next is a 7. Minus 1 means what? It is a I square, and again this divided by 16. Okay, now we'll take the 2 as a common. The square root of I square is I, and here we write here, therefore again here x is equals to minus 2 plus or minus 2 root of 7i, and this whole divided by 16. Okay, I square. Okay, the square root of I square is I. Now we'll take the 2 as a common. Therefore here you will get, as you take the 2 as common, minus 1 plus or minus root of 7i, and this divided by 16. And if we simplify it, then you will get 1 and this 8. Therefore x is equals to minus 1 plus or minus root of 7i upon 8. Therefore the roots of this quadratic equation is, therefore the required roots are, that is x is equals to minus 1 plus root of 7i upon 8, or minus 1 minus root of 7i upon 8. These are the roots of this equation. This can be again written as, therefore the required roots are x is equals to minus 1 plus root of 7i upon 8, and x is equals to minus 1 minus root of 7i upon 8. These are the required roots. In this way we can solve this quadratic equation. The roots of these quadratic equations are the complex roots. Okay, this type of examples we have solved in 10th standard, but at that time the discriminant was negative and we say that the roots are not real, but here the roots are complex. Now this second problem, that is the third one here from the textbook. 3x square minus 7x plus 5 is equals to 0. Again the same dialogues here, that is the comparing with ax square plus bx plus c is equals to 0. Now here we will substitute the values of a, b, c. Now what are the values of a, b, c here? The a is equals to 3, I will write here. A is 3. What about the b? B is minus 7. What about the c? C is equals to 5. We will find out the value of this discriminant. Okay. Now here b square minus 4ac. The value of b is minus 7 bracket square minus 4. A is 3 and c is 5. Therefore Here you will have 49. Next 4 into 3, that is a 12. 12 into 5 minus 60. Okay, what about their subtraction? That is a 49 minus 60, that is equals to minus 11. This is the value of the delta, and which is less than 0. Again the roots are complex. Here again we will apply the formula x is equals to minus b plus or minus in root of b square minus 4ac upon 2a. We'll substitute the values. What is that? First, the value of b. b is minus 7, minus in bracket minus 7 plus or minus the square of in root of, that is a minus 7 bracket square minus 4 into a. The value of a is a 3 and the value of c is 5. The value of c is 5, and this whole divided by 2a. 2 into 3 is a 2 into 3, and that is equals to 7 plus or minus in root of 7 minus 7 square, that is a 49. That's we have calculated its value. We'll substitute the values, that is minus 49 minus 60. Okay, and this divided by 2 into 3, that is equals to 6. Again here we can write 7 plus or minus in root of minus 11 upon 6, and again this can be written as, that is 7 plus or minus root of minus 11, again can be written as 11 into minus 1 upon 6. Okay, and that is equals to 7 plus or minus in root of 11 into I square, 11 into I square upon 6, and the square root of I square is I. Therefore again this can be written as 7 plus or minus root of 11 I upon 6, and therefore the required roots are the required roots are what are the required roots? 7 plus root of 11i upon 6, and second root is and 7 minus root of 11i upon 6. These are the required roots. In this way we can solve the quadratic equation by using the formula, and here important thing is that the roots are complex. Now we'll take the next question. Now the next question, that is a question number 3. Solve the following quadratic equation. The first is x square plus 3ix plus 10 is equals to 0. Now again the comparing with ax square plus bx plus c is equals to 0. The value of a, that is the coefficient of x square, is here 1. Coefficient of x is 3i, and the coefficient of c is 10. Next we will find out the value of this discriminant delta, that is b square minus 4ac. The value of b is 3i bracket square minus 4a. A is 1 and c is 10. Okay, that is 3i square means what? 3 square and I square means what? 9i square. Here is a 9i square minus 4 into 1, that is 4 into 10, that is equals to 40. 3i square is minus 1 into 9. Therefore, it is a minus 9 minus 40, and that is equals to minus 49. Okay, this is the value of delta, and delta is equals to minus 49. Delta is negative, therefore the roots of these quadratic equations are complex. Okay, now we'll substitute the value of again in this formula. X is equals to minus b plus or minus in root of b square minus 4ac upon 2a. Now first of all, what is the value of a? A is minus 3i plus or minus in root of b square. B is again 3i. We have calculated its value, minus 4ac. A is 1 and c is 10. A is 1 and c is 10. This whole divided by 2 into 1. Okay, and this equals to minus 3i plus or minus. We have calculated the value of this delta, and that comes to, that is the in root of minus 49 divided by 2. And this 49 can, minus 49 can be written as 3i plus or minus 49 into minus 1, and this divided by 2. Okay, and next is a minus 3i plus or minus the square root of 49 is a 7, and root of minus 1 is I square, and the square root of I square is I, therefore here is a 7, and this divided by again 2. Therefore we have the two values of x minus 3i plus or minus 7i upon 2. Now here we will take the x is equals to minus 3i plus 7i upon 2. Once we take the plus sign, and another is, and here minus 3i minus 7i, and this divided by 2. Here I will write here, that is, and x is equals to, okay, minus 3i plus 7i, that is a 4i. Therefore here you will get 4i upon 2, and here x is equals to minus 10i upon 2. If we divide it, then you will get x is equals to 2i, and here x is equals to minus 5i. The roots are complex, okay, and therefore the required roots are x is equals to 2i and x is equals to minus 6i, and x is equals to minus 6i. These are the roots of this given quadratic equations. This is the answer. Now we'll take the next example. And hence we can write the answer, x is equals to 2i and x is equals to minus 5i. And therefore the required roots are x is equals to 2i and x is equals to minus 5i. These are the required roots. Now we'll take the next example. Now the next example is x square plus 4ix minus 4 is equals to 0. Again comparing this equation with ax square plus bx plus c is equals to 0. Now here again the value of a is 1, I will write here. Value of b is 4i and the value of c is minus 4. Again, the discriminant delta is equals to b square minus 4ac. We will substitute the value, that is a 4I bracket square minus 4ac. A is 1 and c is minus 4. Okay. Now 4I square, therefore you will get 16I square here. Next is a 4 into minus 4 into minus 4, that is a plus 16. Okay, here is a 16, I square is minus 1, therefore 16 into minus 1 plus 16, and overall here you will get minus 16 plus 16, and that's equals to 0. Therefore the value of this delta, that is a discriminant, is equals to 0. Now here we'll substitute again the values of a, b, c. B is 4I, b is 4I minus 4I plus or minus, and the value of this discriminant is 0, that is the root of 0 upon 2 into a. The value of a is 1 minus 4I upon 2, and that is equals to minus 2I, and hence the root of this quadratic equation, that is the x is equals to minus 2I. Therefore the roots are, that is, it's a simple single one, that is equals to minus, x is equals to minus 2I. Hence we can solve this type of equation by using the formula, and the roots of these quadratic equations are the complex root. Now we'll take the next question. Now the question number 4, again solve the following quadratic equations. The first equation is, this is the question number 4, x square minus in bracket 2 plus I into x minus in bracket 1 minus 7I, and that's equals to 0. Again the same thing is here, the solution. Comparing with ax square plus bx plus c is equals to 0. Here a is equals to 1, b is equals to minus in bracket 2 plus I, c is equals to minus in bracket 1 minus 7I. Here we will find out the value of the discriminant, that is the b square minus 4ac. Okay, the value of b is minus 2 plus I bracket square minus 4ac. 4, a is 1 and c is minus 1 minus 7I. Okay, and the square of this term, that is a 2 plus I bracket square, 2 plus I bracket square, this minus and minus, that will become plus, that is a 4 in bracket 1 minus 7I. 2 plus I bracket square, that is a 2 square means 4, plus 2 into I, that is 4I, plus I square plus 4 minus 28I, that is 4 into 1 4, 4 into 7, that is a 28. Next is 4 plus 4, that is a 8, plus 4I minus 28I, and that you will get minus 24I. I square is minus 1, and hence here you will get 8 minus 1, that is a 7 minus 24 I. This is the value of delta, that is a b square minus 4ac. This value of the delta. Now next, now the given equation has the complex root and it is given by the formula. What is that formula? The formula is x is equals to minus b plus or minus in root of b square minus 4ac upon 2a. X is equals to minus b. The value of again this b is minus in bracket minus 2 plus I plus or minus in root of b square minus 2 plus I, okay, it's a bracket square minus 4a. The value of a is 1. A is 1. And next, the value of c is minus in bracket 1 minus 7i. Okay. And this whole divided by, that is a 2 into the value of a is 1. This is the big expression. So this x is equals to minus and minus, that will become plus 2 plus I plus or minus in root of, okay, in root of 2 plus I bracket square, and this minus and minus again that will become plus 4 1 minus 7i, and this again whole divided by 1 into 2 is 2. Next is 2 plus I plus or minus, we'll simplify this. What is here? That is a 2 square means what? 4. 2 into 2 into I, that is a 4i plus I square. 1 into 4 is 4 minus 28i, and again this whole divided by 2. Okay, this divided by 2. 2 plus I, 2 plus I plus or minus in root of, okay, normal simplification is here, that is 4 plus 4, that is 8, and I square is minus 1. 4 plus 4 is 8, I square is minus 1, and again 4i minus 28i, and that is you will get minus 24i. That's we have calculated here the value of this delta, and we'll substitute here upon 2. You can directly substitute the value of that delta 7 minus 24i, that is also sufficient, but I had written here for the, it was your first example, 2 plus I plus or minus in root of 7 minus 24i, and this whole divided by 2. This whole divided by 2. Again we want to find out the square root of 7 minus 24i. Now to find out the square root of 7 minus 24i, I can write here, let the square root of 7 minus 24i is p plus qi, okay, and that is equals to in root of 7 minus 24i, where p comma q belongs to set of real number. Now squaring on both sides, therefore you will get p plus q, p plus qi, that's squaring on both sides, you will get 7 minus 24i. Now expand this, okay, this you will get, that is a p square plus 2p q I plus q square I square minus is equals to 7 minus 24I. And here I square is minus 1, therefore you will get here p square minus q square plus 2p q I is equals to 7 minus 24I. Okay, now here the value of p square minus equate the real and imaginary part. We have solved this type of example, that is a p square minus q square, that is equals to 7 and 2p q is equals to minus 24, that equating the real and imaginary part. Here again pq is equals to minus 12, divide on both sides by 2. Therefore the value of q is equals to minus 12 upon p. Now substitute the value of q here, therefore you will get here p square minus q square is equals to 7, p square, the value of q, minus 12 upon p bracket square, and that is equals to 7. Now evaluate this. Again p square minus 144 upon p square is equals to 1. Now we'll simplify here, that is a p raised to 4 minus 144, that is equals to 7p square. This is the quadratic equation in p square. We can write it in this manner, that is a p raised to 4 minus 7p square minus 144, and that's equals to 0. Now the factors are the minus 16 and plus 9, therefore p square minus 9 minus 16 plus into p square plus 9, and that's equals to 0. Again the evaluating this, you will get p square minus 16, and that's equals to 0. P square minus 16, that's equals to 0. And next is a p square plus 9 is equals to 0. Again here p square is equals to 16, we will get here p square is equals to 16, and next is p square is equals to minus 9. But p and q, these are the real number, and therefore p square is equals to minus 9 is not possible. Therefore what is the value of p square? P square is 16. If you take it's a square root, p square is 16. If you take the square root, then you will get p is equals to plus or minus 4. Therefore what is the value of q? The value of q when, I will write here, when p is equals to 4, then the value of q, I will write here directly, minus 12 upon 4, and q is equals to minus 3. Next, when p is equals to minus 4, q is equals to, q is equals to minus 12 upon minus 4, and that is q is equals to 3. P is equals to 4, q is equals to minus 3, and p is equals to minus 4, and q is equals to 3. These are the two different square root of this expression. What is that? P, that is the 4, 4 minus 3r, and we can compact this in the two different ways. That is the, what is that? 4 plus or minus 4 minus 3i. Okay. Now next is, again we will come here and I will write here big example. Therefore, what is there? That is the x is equals to 2 plus I plus or minus. Okay, plus or minus, again the same thing is here, that is a plus or minus, there are the two different roots, plus or minus 4 minus 3i upon this whole divided by 2. Therefore once x is equals to, here x is equals to 2 plus I plus 4 minus 3i and this divided by 2, and x is equals to 2 plus I minus 4 minus 3i and this divided by 2. Therefore here you will get 2 plus 4, that is a 6, I minus 3i, that is a minus 2i upon 2, and the next is x is equals to 2 plus I minus 4 plus 3i, this whole divided by 2. If we take the 2 as a common, then the roots are, that is if we take the 2 as common, that is the 2 in bracket 3 minus I and this whole divided by 2, then 2 will get cancelled, and next is x is equals to, what is here? Plus 2 minus 4, that is a minus 2, and the next is a I plus 3i, that is a 4i, and this divided by 2. Again we will take the 2 as a common, therefore you will get, if we take the 2 as common, minus 1 plus 2i and this whole divided by again 2. Therefore the roots are x is equals to, that is x is equals to 3 minus I, and next root is x is equals to minus 1 plus 2i. These are the roots of the quadratic equation. What are the roots? X is equals to 3 minus I and x is equals to 1 minus 2i. Now we'll take the next example. Now the next is second example, that is a 2 plus I into x square minus 5u, that is this is the third example. 2 plus I bracket complete into x square minus in bracket 5 minus I into x plus 2 in bracket 1 minus I bracket complete is equals to 0. Again comparing with ax square plus bx plus c is equals to 0. The value of a is 2 plus I, b is equals to minus 5 minus I, c is equals to 2 1 minus I. Okay, now here again we'll find out the value of the delta. Delta is equals to b square minus 4ac. Okay, the value of b is minus 5 minus I bracket square minus 4 AC is 2 plus I and into 2 in bracket 1 minus I, and the square of this is 5 minus I bracket square 4 into 2 8, that is a minus I minus 8, and again next 2 plus I and 1 minus I. Now 5 minus I bracket square, that is a 25 5 square, minus 2 into 5 into I, you will get minus 10I plus I square minus 8, and the product of these two bracket 2 into 1, 2 into 1 is 2, 2 into minus I minus 2I, I into 1 plus I minus I, that is a minus I square. We'll evaluate this, that is a 25 minus 10I, and I square is minus 1 minus 8, and next in bracket 2 minus 2I plus I square is minus 1, and here we'll write here, and next is a 25 minus 10I, okay, minus 1 minus 8, and in bracket 2 minus 2I plus I, you will get minus I, and yes, minus and minus, that will become plus. Okay, next is again 25 minus 1, that is a 24 minus 10I. Next is minus 8, and in bracket 2 plus 1, that is equals to 3 minus I. Now we will evaluate it, that is a 24 minus 10I minus 24, and this minus and minus, that will become plus, that is 8I, plus 24 and minus 24 get cancelled, and here you will get minus 10I plus 8I, that is equals to 2I, and this is equals to delta. Now the roots of this quadratic equation, x is equals to minus b plus or minus in root of b square minus 4ac upon 2a, and therefore x is equals to minus b. Here is a, what is the value of b? B is a minus in bracket minus 5 minus I bracket complete plus or minus, I have just calculated the value of the b square minus 4ac, and that is a minus 2I, and I will write here, this is the in root of, okay, b square minus 4ac, that is equals to minus 2I, and this whole divided by 2 into a, that is a 2 in bracket, sorry, the value of a is, sorry, 2 in bracket 2 plus I. This is the value of x. Now we'll open this sub bracket, that is we simplify again, that is x is equals to this minus and minus, that will become plus 5 minus I plus or minus in root of minus 2I, and this whole divided by 2 in bracket 2 plus I. Now we'll calculate the, we'll find out the root of minus 2I. Again, let, that is the square root of minus 2I is equals to p plus qi. That is another complex number, and this equals to minus 2I, where p comma q belongs to set of real number. Now squaring on both sides, then you will get p plus qi bracket square is equals to minus 2i, and here p square plus 2p qi plus qi bracket square, and that is equals to minus 2i, and here you will get p square plus 2p qi q square I square, and that is a minus q square is equals to minus 2i. We'll collect the real part, that is a p square minus q square plus 2p q I is equals to minus 2i. Again here on the right hand side the real part is 0. There is only the imaginary part, and hence I will write here that is the value of equating the real and imaginary part, value of the p square minus q square, that's equals to 0, and next is a 2p qi is equals to minus 2i. Then I get cancelled on both sides, therefore p square is equals to q square, and next is a p q. 2 get cancelled, I get cancelled, that is a p into q is equals to minus 1. What is the value of q? Here q is equals to, that is a pq is equals to minus 1, therefore q is equals to minus 1 upon p. Now p square q square, p square minus, that is a, again I will write here p square minus q square, that is equals to 0. What is the value of q? Q is minus 1 upon p, therefore here is a p square minus 1 upon p whole square, and that's equals to 0. Here is a p square minus 1 upon p square, that's equals to 0. Now simplify this. This is the p raised to 4 minus 1, and that's equals to 0. Now the square roots, we can write here p square, and it's a bracket square, p square bracket square, and next is a minus 1 and bracket square, that's equals to 0. And therefore here you will have p square minus 1 and the p square plus 1, and that's equals to 0. P square minus 1 is equals to 0, and next is a p square plus 1 is equals to 0. Okay, therefore you will get here p square, or here I will write here, or p square is equals to 1, or p square is equals to minus 1. But p is a real, but p belongs to set of real number, and therefore the square of real number is not negative. P square is not equals to minus 1. Then what is the possible? P square is equals to 1. Now we'll solve this, taking the square root on both sides. Then here you will get p is equals to plus or minus 1. Now we'll find out the value of the q. What is the q is equals to? Q is equals to minus 1 upon p. Therefore when p is equals to 1, then what about the q? Q is equals to minus 1 upon 1, and that is minus 1. And when p is equals to minus 1, q is equals to minus 1 upon minus 1, that's minus minus will become plus. Therefore the root of minus 2i is, what is the root of minus 2i is? That is, the first root is 1 minus I. First root is, the value of p is 1, and q is a minus 1. This is the first root, and the second root and I will write here the second root is a minus 1 and plus I. Minus 1 and plus I. These are the two roots. Now we will substitute these values in this equation. Okay, this is a brief problem. And in the compact form, this root can be written as plus or minus 1 minus I. Okay, the square root of minus 2i is a plus or minus 1 minus I. Therefore, here x is equals to 5 minus I plus or minus 1 minus I upon 2 in bracket 2 plus I. Therefore, x is equals to 5 minus I plus 1 minus I, and this whole divided by 2 in bracket 2 plus I, and another is x is equals to 5 minus I minus in bracket 1 minus I, and this whole divided by 2 in bracket 2 plus I. Now we will simplify this. Therefore, x is equals to 5 minus I plus 1 minus I, and this whole divided by 2 in bracket 2 plus I. What about the next? And here again x is equals to 5 minus I minus 1 and plus I. If you open the bracket, minus 1 plus I. Here is a plus I, and this divided by 2 in bracket 2 plus I. Now next is, that is a x is equals to 5 plus 1, that is a 6 minus I minus 2I, and this divided by, that is a 2 in bracket 2 plus I. If you take 2 as a common, then you will get, that is a 3 minus I upon 2 in bracket 2 plus I. These two get cancelled, and here you will get 3 minus I and 2 plus I. What about the other? And here the other part, 5 minus I, here is a 5 minus I, plus I minus I get cancelled, 5 minus 1, that is x is equals to, plus I minus I get cancelled, 5 minus 1, that is a 4, 2 upon 2 plus I. Again simplify this, you will get the value of x is 2 upon 2 upon, if you simplify it, that is a 2 upon 2 in bracket 2 plus I. These are the values of x. X is equals to 3 minus I, and next is 2 plus I, and another value is x is equals to 2 upon 2 plus I. Now again we will simplify this. We will find out the value of this x is equals to 3 minus I upon 2 plus I in a simplified form, and the value of again this x is equals to 2 upon 2 plus I. See this here, x is equals to 2 minus I upon 2 plus I. We will multiply it for this term, numerator and denominator, by the conjugate of 2 plus I. Multiplied here to the numerator and the denominator, 2 minus I and 2 minus I. What about the next? That is x is equals to here 2 upon again 2 plus I, again multiplied this term, that is a 2 minus I, and here 2 minus I. Therefore, here you will get, that is a 3 minus I in first bracket 2 minus I. That is a plus b, a minus b. Therefore, here you will get 2 square minus I square, and next is x is equals to 2 in bracket 2 minus I, and again a plus b, a minus b, it means what? That is a 4 minus I square. Okay, therefore here x is equals to the product of these two, 2 into 3, 6, 3 into minus I, that is a minus 3i, minus I into 2, minus 2i, minus I into minus I, that is a plus I square, and this divided by 2 square is a 4, I square is minus 1, and here is a minus 1, and again x is equals to 2 in bracket 2 minus I square is minus 1, 4 minus 1, and that is equals to 2 minus I, and this divided by, that is I square is minus 1, that minus and minus, that will become plus. Okay, therefore 4 plus 1, that is 5. Okay, therefore the x is equals to, now we will simplify here again, 6 I square is minus 1, 6 minus 1, that is 5. Next is minus 3i minus 5i, and here is a 4 minus and minus, that will become a 4 plus 1, that is 5, and here again that is a x is equals to 2 in bracket 2 minus I upon 5. If you take 5 as a common, then you will get 5 in bracket 1 minus I, okay, 1 minus I upon 5. This 5 will get cancelled, and here you will get x is equals to 1 minus I, and here x is equals to 2 in bracket 2 minus I upon 5. Okay, these are the roots of the quadratic equation in bracket 2 plus I into x square minus in bracket 5 minus I into x plus 2 in bracket 1 minus I, and that's equals to 0. Again in simplified form, that is x is equals to 1 minus I, and 2 into 2, 4, again 2 into minus I, that is a minus 2i. Okay, here is a minus 2i, that is a 2 into I will write here 2. Okay, therefore 4 upon 5 minus 2i upon 5. Therefore the roots of this quadratic equation, that is a in bracket 2 plus I into x square minus 5 minus I into x plus 2 in bracket 1 minus I is equals to 0 is x is equals to 1 minus I, and x is equals to 4 by 5 minus 2i upon 5. These are the roots of this quadratic equation. Now the next problem is find the value of x cube minus x square plus x plus 46 if x is equals to 2 plus 3i. Now the solution. Okay, see this here, x is equals to 2 plus 3i. This can be written as x minus 2 is equals to 3i. Squaring on both sides, then you will get x minus 2 bracket square is equals to 3i bracket square. Therefore here you will get x square minus 4x plus 4, and the square of 3i is 9i square. I square is minus 1. Therefore, x square minus 4x plus 4 is equals to 9 in bracket minus 1, 9 into minus 1, and hence it can be written as x square minus 4x plus 4. 9 into minus 1, that is a minus 9. When we simplify it, that will become plus, and here that's equals to 0. Bring this minus 9 to the left hand side. Therefore, the expression x square minus 4x plus 13, that's equals to 0. Now we'll divide the polynomial x cube minus x square plus x plus 46 by this polynomial x square minus 4x plus 13 in a very traditional manner. That is, here x cube minus x square plus x plus 46. Now we'll divide the polynomial x cube minus x square plus x plus 46 by the polynomial x square minus 4x plus 13. Now always consider what is your first term. First term is x cube. Then by which term? If we multiply by this x to this x square, then you will get x cube. Therefore, I will write here x. X into x square, therefore you will get x cube. X into minus 4x, then you will get minus 4x square. X into 13, that is a plus 13x, and next is change the sign, minus, it is a plus, and again minus. Plus x cube minus x cube get cancelled, and next is a minus x square 4x square. Then you will get here 3x square plus x minus 13. Then you will get minus 12x plus 46. Again multiply this. We want that is a 3x square. Then by which terms we should multiply to this x square, then and then we will get 3x square. That is, here is a plus 3. That is 3 into x square, 3x square. 3 into minus 4x, that is a minus 12x. 3 into 13, therefore you will get 39. Again the division, change the sign, minus plus, and the minus, this get cancelled, again this get cancelled, plus 46 minus 39, and here you will get, that is the 7. Okay, now by the division algorithm, by division algorithm, now I will explain again here. We'll divide the x cube minus x square plus x plus 46 by x square minus 4x plus 13. Now see this here, the first term is x cube. To get the x cube, we will multiply to this x square by x. Therefore here we will write here x. X into x square, that is x cube. X into minus 4x, that is a minus 4x square. X into 13, that is a 13x square. And we will change the sign when we divide it. That is, here is a plus sign, minus, minus, plus, plus, and minus. Now here x cube minus x cube get cancelled. Minus x square and plus 4x square, you will get 3x square. Plus x minus 13x, you will get minus 12x, and plus 46. Again next, to get the 3x square, we have to multiply this x square by 3, and therefore we will multiply here. I had written here 3. 3 into x square, therefore you will get 3x square. 3 into minus 4x minus 12x. 3 into 13, that is a 39. Again, as there is a division, we will change the sign, plus to minus, minus to plus, plus 2 minus again 3x square minus 3x square get cancelled, plus 12x minus 12x get cancelled, and plus 46 minus 39, and you will get the 7. Therefore, by the division algorithm, okay, by the division algorithm, here dividend is equals to divisor into quotient plus remainder. I will write here R only. Okay, and we will substitute the values. What is the divisor? The divisor is x cube minus 4x plus 13. X square minus 4x plus 13. What about the quotient? Quotient is x plus 3. There is a quotient x plus 3. And what about the remainder? Remainder is 7. But what is the value of x square minus 4x plus 13? Its value is 0. And therefore 0 into in bracket x plus 3 plus 7, and you will get the value is 7. Therefore the value of the polynomial x cube minus x square plus x plus 46 is 7, and in this way we can find out the value of the polynomial. Now the third problem is x cube plus x square minus x plus 22 if x is equals to 5 upon 1 minus 2i. Now here the x is in this manner, in this fashion. See this here, x is equals to 5 upon 1 minus 2i. We will simplify here. Multiplied the numerator and the denominator by the conjugate of 1 minus 2i, which is 1 plus 2i. 1 plus 2i. Now the product of this is, that is a 5 in bracket 1 plus 2i, and here is 1 minus 2i into 1 plus 2i, that is a minus b into a plus b, that is a 1 square minus 2i bracket square. Therefore here you will get 5 in bracket 1 plus 2i upon, that is a 1 minus 2i square, means what? 4i square. It is a 4i square, and that is 5 in bracket 1 plus 2i upon I square is minus 1, that is 1 minus 4 into minus 1, and overall you will get 5 in bracket 1 plus 2i, and this divided by 1 plus 4. Therefore here you will get x is equals to 5 in bracket 1 plus 2i upon 5. This 5 get cancelled, you will get 1 plus 2i. Therefore x is equals to 1 plus 2i, and this can be written as x minus 1 is equals to 2i. Now the squaring on both sides, here you will get x minus 1 bracket square is equals to 2i bracket square. Now we will simplify here, x minus 1 bracket square, then you will get x square minus 2x plus 1, and the square of 2i is 4i square. I square is minus 1, and hence this can be written as x square minus 2x plus 1, and that is equals to minus 4, because I square is minus 1, 4 into minus 1 is minus 4, and hence again this can be written as, that is a x square minus 2x plus 1, and plus 4 and that's equals to 0. Therefore x square minus 2x plus 5 this equals to 0. Now we'll divide the polynomial x cube plus x square minus x plus 22 by x square minus 2x plus 5 is equals to 0. That is in this manner. X cube plus x square minus x plus 22. That is we divide here. That is the x square minus 2x plus 5. Now consider this first term is x cube. To get the x cube, we have to multiply this x square by x. Therefore, here I will write here x. Now x into x square, you will get x cube. X into minus 2x, that is a minus 2x square. X into 5, therefore you will get here 5x. As there is a division, we will change the sign minus. Here is a plus and again minus. Plus x cube minus x cube get cancelled, and plus x square minus plus 2x square, you will get 3x square minus x and minus 5x, you will get minus 6x plus 22. Next is again here consider the first term. Here is a 3x square. Therefore we have to multiply to get the 3x square. We have to multiply this x square by 3. Therefore I will write here 3. Therefore multiply this 3 to all these 3 terms. 3 into x square, we will get 3x square. 3 into minus 2x minus 6x. 3 into 5, that is 15. Okay, and change the sign minus plus and again minus. Okay, plus 3x square minus 3x square get cancelled, plus 6x minus 6x get cancelled, 22 minus 15, and here you will get the 7. Again in the standard form, dividend is equals to divisor into quotient plus remainder. We will substitute the values. What was the divisor? The divisor was x square minus x square minus 2x plus 5. X square minus 2x plus 5 into quotient. The quotient is x plus 3. Here quotient is x plus 3 plus remainder. Remainder is 7. Now see this here. The value of x square minus 2x plus 5 is 0. Therefore 0 into x plus 3 plus 7, and that is equals to 0 plus 7, and hence the answer is 7. Therefore the value of the polynomial is 7 when x is equals to 5 upon 1 minus 2i, and the polynomial is x cube plus x square minus x plus 22. Now the fifth problem is 2x raised to 4 plus 5x cube plus 7x square minus x plus 41 if x is equals to minus 2 minus root 3i. Okay. I will write here x is equals to minus 2 minus root 3i, and this can be written as x plus 2 is equals to minus root 3i, squaring on both sides. Therefore you will get here x plus 2 bracket square. Okay, and here is a minus root 3i, it's a bracket square, and it's a square is a plus 3i square. Now expand this, x square plus 4x plus 4, 3i square is minus 1, and overall you will get minus 3. Again after simplifying here, x square plus 4x plus 4 plus 3, and that's equals to 0, and therefore x square plus 4x plus 7, that's equals to 0. Now we'll divide the polynomial 2x raised to 4 plus 5x cube plus 7x square minus x plus 41 by x square plus 4x plus 7. Now again see this here. Okay, that is a 2x raised to 4 plus 5x cube plus 7x square minus x plus 41. We'll divide this polynomial by x square plus 4x plus 7, x square plus 4x plus 7. Now see this, what is the first term here? 2x raised to 4. To get 2x raised to 4, we have to multiply this x square by 2x square. Therefore, I will write here 2x square. 2x square into x square, you will get 2x raised to 4. 2x square into 4x, then you will get, that is a plus 8x cube. 2x square into 7, then you will get plus 14 into x square. Again there is a division, we'll change the sign. It's a minus, minus, and again minus. These two get cancelled. 5x cube minus 8x cube, that is a minus 3x cube. Okay, plus 7x square minus 14x square. Then therefore you will get minus 7x square minus x plus 41. Again see this polynomial, that is a minus 3x cube minus 7x square minus x plus 41. Again to get minus 3x cube, we have to multiply this x square by minus 3x. Therefore I will write here minus 3x. Minus 3x into x square, you will get minus 3x cube. Again minus 3x into plus 4x, therefore you will get minus 12x. Minus 3x into 7, that is you will get minus 21x. Again change the sign, here is a plus, plus, and again plus. Minus 3x cube plus 3x cube get cancelled. Minus 7x square plus 12x, here is a 12x square. Okay, minus 7x square plus 12x square, therefore here you will get 5x square plus x and plus 21x, sorry, minus x and plus 21x, you will get plus 20x plus 41. Now to get 5x square, we have to multiply this x square by 5. Therefore I will write here plus 5. Therefore 5 into x square, you will get 5x square. 5 into 4x, therefore you will get 20x. 5 into 7, that is a plus 35, and here change the sign, minus, minus, and minus. Here you will get cancel, in this get cancel. 41 minus 35, and you will get here 6. Again by the division algorithm, dividend is equals to divisor into quotient plus remainder. Now what was divisor? The divisor was x square plus 4x plus 7, and the quotient is 2x square minus 3x. Quotient is 2x square minus 3x plus 5. What about the remainder? Remainder is 6. Okay, now the value of this polynomial is 0, that is x square plus 4x plus 7, that's it's a 0. Therefore 0 into this polynomial, that is a 2x square minus 3x plus 5 plus 6. and overall you will get 0 plus 6, and that is equals to 6. Therefore the value of the polynomial is 6. What was the polynomial? 2x raised to 4 plus 5x cube plus 7x square minus x plus 41 if x is equals to minus 2 minus root 3i. And in this way I had completed in another frame. Number of the students says that, sir, teach on the whiteboard. Now this is my first video I am teaching on the whiteboard. Now we'll see in the next video. Till then, goodbye.